Hi, my name is Eduardo Ox. I'm the author of an Emacs package called Eev, and the name of this video is Eev and TikZ, or how to learn tiks using a REPL. And this is a picture of me in a REPL. You can see that I'm very happy because I have a REPL with me. This video complements what is in this page here. So I'm going to use lots of technical terms that are explained in the web page, and I'm not going to explain them here. First of all, I tried to learn tiks the first time many years ago in 2014 and I failed miserably many times. I've tried it several times, and every time I gave up with the feeling that my brain was too small for learning tiks. And about 1 month ago, I finally found a way that worked for me for studying tiks, and it used links to the manual. I'm going to show them in a minute. I mean, links to both the PDF of the manual and to the source code of the manual. A REPL that I can run from Emacs, and a way to extract examples from the manual. Let me show a first example here. This link here, I will have to use a smaller font. This link here opens my file with notes about tiks. You can see that it's, it's very big. It has about 4,000 lines at this moment, and it's very messy. This thing here is an index. Some of the sections are good, some of the sections are totally crap and whatever. And this link here goes to the section that I want to discuss. So this goes to this section here about horizontal and vertical lines. And these first links here point to the manual. If I open this one, note that it ends with page here. It opens a page of the manual in the usual sense, in the sense that it opens a PDF. It opens the PDF of the manual at this page here. And this is a comment that the function find tiksman page ignores. So the comment is just for humans. So if I execute this, it takes a few seconds because the PDF is very big, and it opens the PDF on page 152, and what I'm going to show is something related to this example here. So the manual explains that sometimes we want to connect 2 points via straight lines that are only horizontal and vertical, and for that we can use this notation and this one. And it gives this example here, so this is the output of the example, and this is the source code of the example. Let me go back. If I execute this sexp here, it will take several seconds to run because it will have to run a program called PDF to text to convert the PDF to text, and the manual is huge. It's about 1,300 pages. So it takes a while, and then it is going to go to the page 152 of the manual converted to text. It finds that page by counting form feeds, and then it will show this string here in the converted text. So we still have to wait a bit. Here. So this is the name of the command that was run to generate the converted version. And if I do not delete this buffer, then going back to the manual is very quick. So if I execute this again, it goes back to the manual immediately. And note that this corresponds to this section of the manual here. And the first obvious way to extract the source code of this example here is to simply take this text here copy these to my notes and edit this a bit to delete everything from this column to the left. And note that there's an A and a B here. These letters are there because here in the manual, in the example, we see an A and a B here in the image. Until a few weeks ago, when I was extracting examples from the manual, I was always using this conversion to text here, and I was editing these things by hand. But then I realized that maybe I should take a look at the source code of the manual. That's a huge text .tag file, and I could try to see how these sections and these examples are coded in the manual. And it turns out that it's very easy to extract the examples from the manual. If I execute this section here, note that the suffix is file. This thing here opens a file with this name in a certain directory and searches for the first occurrence of this string here. And what we get is this. Here is one of the files in the source code of the manual. Here we have a listing of everything in this directory. So we have lots of files that start with pgf manual blah blah blah. And we find a subsection with this title here. And one second. And here we have this block that starts with begin code example and ends with end code example. And this is exactly the source code that I want. So I realized that in many cases it was much easier to simply extract this code here from the source code of the manual and then try to run that code. Anyway, let me go back again. Remember that I said that I found a way of testing the examples in the manual using a REPL. This is a demo of this REPL. I'm going to explain it in details very soon. Now I just want to demonstrate how it works. If I execute these 3 lines here, then Eev will create a target buffer running Lua in the right half of this frame. Let's do that now. So we have this, and now if I execute this line here, it will make Lua load a certain file. That is the REPL, the tricks with the REPL that I'm going to explain soon. And this thing here defines a drawing in tiks. And when I run this line here, show, it takes a few seconds because it produces a tag file, it saves the tag file to disk. This section here visits the tag file. It is just this. So it has a header, a footer, and this thing in the middle. And it said that the class show compiled this tag file and everything went well. It means success. And now I can run this thing here. Note that this is a red star line, so Eev interprets everything at the right of the red star as Lisp and executes that as Lisp. And when I do that, it will show the PDF here. And the nice thing is that I can make changes to this drawing. For example, I can change the scale of the drawing, and then I can recompile everything and show the PDF again. And you can see that the PDF is always shown here, so it's very easy to compare one version with another. And by the way, I can even execute these lines here in another order. For example, I can execute this one and then skip the second one and then run the show and the tiks show. And so I've just changed the parameter in the drawing, and I produced a new version, and I showed the PDF of the new version. So this is the way that the REPL works. There are several variants of these Lisp function here that shows a PDF. One of the variants is this one. I can run tiks show tag, and let me copy these things here. The scale appears here inside of the scale box. So if I change the scale to 1.5 and I save the tag again and I run show tag again, this 2 here will change to something else. Will change to 1.5. Let's see, pay attention here. Ta-da! And that's it. And now I'm going to show how to run, how people can test this by installing just 4 files. And then I'm going to show a series of exercises that I have prepared for people who want to take this more seriously and who want to use this to study tiks by extracting examples from the manual. By the way, let me just explain one thing that is very interesting and very weird that will appear later. That is this line here. This function, this is an alias for the function find tiks search. I don't remember. Let me try. Tiks with an S at the end is an alias for find tiks search links. And when I run this, it produces a temporary buffer with several SEXPs that I can use for locating an example in the manual. I mean, both in the PDF of the manual and in the source code of the manual, and other related things that we are going to see soon. Let me stop this video, and the part 2 starts in a few seconds. Hi, I'm back. This is the part 2 of the video. In the page about Eev and TikZ, the section 4 is called Trying It. Let me show it here, bigger font. The instructions are here. We are going to copy this thing to a buffer in Emacs. But let me just make some comments before doing that. We are also going to execute a function here that will show a certain script that contains tests that we will run. The prerequisites are quite minimal. We just have to have Emacs, Eev, PDF tools, that is a package that is in Melpa, Lua, and the text distribution with tiks. And let's show how these things work. But before showing this, let me go back to here and make some comments. These red bullets here, they will behave as red stars, even if they do not show in red. This is explained here in the main tutorial. It says that it is possible to make other characters play the role of the red star, and by default, the bullet can play the role of the red star. And we can run this thing here to make the bullets appear in red, but I'm not going to do that now. And the second comment is that lines that start with 2 red stars are treated as comments and are skipped. So let me copy this thing here to my Emacs, to a buffer. I'm running an Emacs in a quite minimal setting in a temporary directory. This is the home directory that I'm using. So it's a fake home directory with just a few things. I have just installed PDF tools here. And let me copy this script here. I will have to use a smaller font. Note that these bullets do not appear in red, but that they are going to behave as red stars, I promise. So F8 here, 3 times create a target buffer running a shell. Then I'm going to run these things here, and here we see 4 wgets. And now I'm going to load this file here. Note that it corresponds to this file here. It defines a few functions. One of these functions is this one that just displays a temporary buffer. Let me run it now. It has this temporary buffer here with some with a script with tests. We have just run a code that corresponds to this section here, to the section 0 here called basic installation, and now we are going to run this thing here. These lines start with 2 red stars, so they are going to be treated as comments, and we are going to see here in the echo area something that says comment blah 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 blah. So let's do that now. And now this line here is going to be very important. Note that this has a single red star, so it's not a comment, it's going to be executed as Lisp, and it sets an environment variable that says where Lua should read its init file from. If I remember correctly, that variable is not set now, so if I execute this thing here, Lua will complain that this function eudo file is not defined. So let me run this block again. When I run this line, Emacs will define this environment variable for all children processes, and I'm going to restart the Lua interpreter here, and now it's going to use this environment variable here. So now this line will work. It will load this Lua file here. We can also execute this with meta-e to take a look at this file. By the way, it says find ang not configured. Let me cheat a bit. Let me run one thing here without explaining it. I'm going to explain this in one of the exercises, I promise. Anyway, if I run this thing now, then it accesses that file by using wget. I mean, it downloads a copy of that file without saving it to disk. And I do not have Lua mode installed in this minimal setting here, so the colors are a bit boring. But anyway, we can access this Lua file here, and now let's run this test. This test is a bit simpler than the test that I've shown before. I'm going to run these 4 lines here, and note that this thing has a tiks here. If I just executed this, then the value of tiks body would be just this string here that is between these funny delimiters between these and these. But we had a tiks here, and this says that we have to run the function tiks with this argument, and the function tiks takes this argument here and treats this thing here as something that has to be expanded. So every time that we expand this string here, this thing here between double angle brackets will be replaced by the result of evaluating it, and also this thing here, and also this thing here. In the beginning, this variable is nil, this variable is also nil, and the function that evaluates these things between double angle brackets treats things that evaluate to nil as empty strings. So this thing here is going to become an empty string. Also this one here. But in this one here, something different is going to happen. The variable grid size is nil, but we have this OR here. So this thing is nil, and the result of this bigger expression is going to be this string here. So this part here is going to, the result of evaluating this part here is going to be this string here. I have sent this thing without the tiks. Let me run this thing again with the tiks. And now let me run the show that will save this thing into a text file. I mean, it will produce a text file, it will save the text file, and it will try to compile the text file to generate a PDF. Ta-da, success. Now I can run this thing here. Remember that it starts with the red file, so Emacs is going to execute this thing. 1 second. Let me try this again. Sorry. I forgot that I'm in a very minimal environment, so it wasn't searching for PDF tools in the right place. Anyway, note that I have executed this thing that is a function. It's a relatively low-level function. It just splits the frame into two windows, and it shows a PDF in the window at the right. We are going to see something much better in a few minutes. Now I'm going to run these lines here. These two lines are sent to the Lua REPL. This line also, but this one takes a few seconds to run, and then it shows all these messages here. And now I'm going to run this line here, define PDF tools R page. And it shows a changed version in which grid options now, I mean, this thing here now, when it is expanded, it becomes this string here. So the grid appears in a lighter color. And now I'm going to run this block here, and this is going to change the value of the variable grid size. Remember that grid size appears here. So when I change this variable grid size to this string, the result of evaluating this expression here is no longer going to be the thing at the right of the OR. I mean, this string here. It's going to be this other string. So tiks is going to use a smaller grid. Here we have a grid that is whose width is 6 units and its height is 4 units. We're going to change that to 4 units and 3 units. Let's do that now. Show takes a few seconds to run because it produces a PDF, and now let's show the result. Ta-da! Smaller grid. And here is another part of the demo. Instead of displaying the PDF, I'm going to use the function's saveTag that just produces a tag file but does not generate a PDF from it, and this function here that displays the tag file at the right side. Let's see. Note that this first line is going to set grid options and grid size to nil and nil again, so we are back in the initial situation. saveTag just says saved the tag file in blah blah blah. And now I'm going to run this thing here that produces a window setting with 3 windows, and it shows the tag file here at the bottom. And now I'm going to run this other block here, and note that I'm changing the grid options, and grid options appears here after the first draw. So pay attention to what happens here in the tag file. We're going to see that here appears, I think, between square brackets that says color equals to gray, exclamation point, 20. So pay attention here, save tag, and now show tag. Ta-da! Now something similar, but the grid is going to change to 4-3. Pay attention here. So this is a tiks show tag as a low-level function that we can use to inspect what happens with the tag file. Well, whatever. And now I'm going to show the function that we're going to use most. That is the function that instead of showing the tag file here, it shows the PDF file here. So same thing, let's reset grid options and grid size to the initial state. Show and tiks show. So this is our initial drawing. The grid appears in black. Now let's show change the color of the grid and run show again and run tiks show. And now it's going to change the changed version of the PDF in which the grid appears in light gray. And now let's change the size of the grid. The grid is currently 6 units by 4 units. It's going to change to 4 units by 3 units. That's it. You can see that the rectangle is smaller now. So this is the basic test that you can run without installing anything. I mean, you just need these prerequisites here. Emacs, Eev, PDF tools, Lua 5.1, and a text distribution with tiks. And by the way, this thing puts 4 files in this directory that is hard-coded at the moment, and it creates some temporary files in /tmp. So now suppose that you're interested in trying this more. Then my suggestion is copy these things here, these lines here, to your init file. Some people use init files with other names, but I prefer to call them by the old name, which is home/tiled/.emacs. But this is an abusive language. I mean, for some people, the init file is going to be tiled/init.el or tiled/.emacs.d/something, whatever. So let's copy these things here to my init file. And now, every time that we start Emacs, it is going to set the init file for Lua to this file here, as I've shown before, and it's going to load the file that defines this script that we're using, and blah blah. Sorry. And if you want to deactivate these things, you just need to comment out this region either in this way or in this way here. Oops, sorry. Let me do this by hand, sorry. One of my favorite keys is not defined. So that's it. This thing was commented out. But right now I do not want it commented out. I want to use it. Note that this thing starts with 3 comments here. I use this a lot in Eev. Instead of using customize, I use set queues and def aliases and the fonts and whatever else. And there is a section here that has links that explain why I prefer to use alternatives to customize, like low-level alternatives, instead of using customize itself. And one trick that I always use is that every time that I put a block of code in my tiled/.mx, and I start with the line that says from, that gives me more information about what these lines do and where I can understand more about them. So if I execute this, I will open this .el file, and note that here we have the definition of find tiks1 links, and it is basically just a big template that displays this thing in a temporary buffer. And it also has a link that goes to a certain anchor in this file that defines that anchor points to the place in which I define the function tik without a z at the end, and it inserts an AEP block that runs tiks1.lua. Let me show how to use this. Let me go back to here. This is just a random scratch buffer. If I run metx tik here, then it inserts this block. Let me show this again. It inserts this block, and this is something that I can modify. I can put this block in any place, and if I run this thing here, it creates a Lua buffer. I mean a target buffer for EEP running Lua. Now this first line loads tiks1.lua that defines tiks and show. And here it has a very short demo of a drawing. The idea is that this is just a placeholder that you can replace by something else. But it's to remind people that you can put tiks code inside this thing here. Now let me run the show. And the tiks show. And this thing drew an orange triangle. I can, for example, replace this by red and run this again. And now my triangle is red. Let me stop this part of the video here. In the other part, I'm going to explain these things here. We have just done the not so basic installation that lets people explore tiks with just a few settings. And now I'm going to explain the exercises that people can use to learn how to extract examples from the tiks manual. So part 3 starts in a few seconds. Hi, this is the part 3 of the video. That is only for the people who are asking, how can I write things like this? Like this block that we saw in the first part, myself. And note that right now, in this minimal setting in which I'm running this MX here in a fake home directory, I do not have a copy of the tiks manual. I do not have a copy of the source of the tiks manual, so many of these things are not going to work. If I execute this thing here, it says that this function is not even defined, this function is not defined also, this function is not defined, so it's not even in a state in which it searches for the manual and for the source of the manual in the right places. What we are going to see is what is in the third section here, in section 3 here, because it has a zeroed section. we just saw what the sections 0, 1, and 2, and we are going to see this one now. Let me just return and execute this. Here we are. I say that the exercises are explained in this section of the page about Eev and TikZ, but at this moment this section does not exist, but it will exist very soon. And there is also another similar function, similar to find tiks1 links, that has some spoilers. At this moment it has very few spoilers, but I'm going to add more spoilers soon. This section has lots of exercises, and I'm going to show in this video I'm going to show very quickly how to do these exercises, and my recommendation is watch this video with subtitles and with the trick that the Eev uses to point to positions in the video, to follow the instructions in each of the exercises step by step. All the exercises are going to be of the same type, which is just reproduce yourself the steps that I'm performing in this video. So they do not require a lot of creativity. They do not require any creativity. It just requires people to familiarize themselves with some functions that I use in Eev. And let me make a very important comment, which is that most of the functions that we're going to see now, they look like 5-minute hacks. My presentation at the EmacsConf 2020 was exactly about that, about some design choices in Eev, and its title was exactly on why most of the best features in Eev look like 5-minute hacks. But let's go back and let me show how to do the exercises. We just saw how to do this exercise here, but this exercise A here, whose name is tik, it asks us to produce meta-x tik to create an image block that compiles and displays a drawing whose body is this. So I'll have to compile this. I'll have to copy this file to my notes. Let me go to my notes here. Remember that when I type meta1 meta-j, this opens the file with my notes, that is home/to-do. So I'm going to put all my notes about these exercises in this file here, which is the file that I recommend people to use to put all their messy things there. So let me yank these lines here. Let me change the indentation, and if I run meta-x tik, it creates a block like this, but the exercise asks us to change the body to this other body here. Now let's run this thing here. I will use a smaller font. It created the PDF successfully. Let's show the PDF. Ta-da! We have agreed with this size, 4 units in the horizontal direction and 3 units in the vertical direction, and this second draw here has drawn a red triangle here. So this was the first exercise. Let me just put some notes here. Now let me go back to the exercises. The second exercise is this one. Let me copy it to my notes. Actually, we have already done that. It says copies the lines from the section 2, blah, 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 to our init file, restart Emacs and check that this thing here work. Let me try. These lines all are already there. I'm not going to restart Emacs because I've started this Emacs with some command line options to make it choose certain colors, and I would take many seconds to remember how to do that. Anyway, so let me pretend that we did the exercise B. Now let's go to the exercise C, which is this one. I have already fixed that, but I did not explain how. The thing is that by default, when we run find es something, Emacs says that that something is not configured. In this case, sorry, let me see what happens here. Oops. So this thing is configured. The instructions say that we have to execute this thing here. Let me just explain how this thing works. If I type meta-x and I run this function here, it shows a way to configure find es and find ang. It explains how they work on my machine, how people can also use it. I mean, when I run find es and find ang in my machine, they open local files that have my scripts, my programs, my notes, and so on. Other people can also access my scripts if they redefine these functions in a certain way to make them use wget. And there's a video here that explains how this thing works. So if people want to understand how what this thing does, the recommendation is watch these videos here. If I remember correctly, they just need to watch 30 seconds starting from this point and another 30 seconds starting from this point. So let me pretend that this exercise is done, and let me go back to the list of exercises. Exercise D. Remember that I said that we don't have a copy of the manual yet. To download a copy of that manual in PDF, we have to run meta-x brep. If we run this here, it asks for a URL, and then it opens this temporary buffer here with a script. If people want to understand what this thing does, they can go to the source code by running this line here, and then the comments in the source code have pointers to the manual, to the place that explains how these things work, and the manual also, and the manual also has some links to videos, if I remember correctly. Oops, sorry, this tutorial does not have links to videos, but it's quite clear. Anyway, to download the local copy, we have to run meta-x brep here, and it displays this temporary buffer, and what we have to do is that we have to execute these comments here. But it says that in my previous test I had already downloaded a copy of the manual, so it's already there. And we can also use these lines here to test if the file was downloaded. It was. And the other part of this exercise says that we have to produce a pair made of a code PDF page and a code PDF text that makes these links work. This is also explained in the tutorial. In the page about Eev and TikZ, I'm going to give links to the sections of the tutorial that explain everything. But let me show very quickly how we can do that. When we run brep here, one of the sexps that it produced was this one. If I, well, now I'm in direct mode, and here I can type meta h meta e. It creates a temporary buffer like this, and what the exercise asks is that we create links like this that work. So the C that we have to put here is tiksman. I have edited this first line here to change the value of curly brackets C, and if I run this line again, it will regenerate this temporary buffer from a template, and all these C's are going to be replaced by this new value here, tiksman. And now we have this block of links that point to a certain PDF file. And what the exercise asks is that we produce this code PDF page and this code PDF text. If I execute them, let me execute them. The first one defines this function here. The second one defines this function here. Remember that if you need more information about what they do, you can just add a find here in the beginning and then execute this new sexp, and then it will have some explanations, a link to the tutorials and so on. But now they have defined these things, and this sexp should work. This one should work, should open the manual in PDF. This is the first page of the manual in PDF. And this sexp here is going to take many seconds because the manual is huge, and it's going to open the manual converted to text. So a bit of patience, please. A bit more, please. Oh no, it takes ages. Ta-da! Here we are. This thing worked correctly. It ran PDF to text to convert the manual to text, and at some point we're going to use this thing to point to titles of sections. Sometimes we're going to use this to copy and paste examples and so on. So the answer to this exercise is these two code PDF, these two code lines here, and these two lines here are tests. Let me go back to the exercises. Now I'm going to show how to do the exercise E. The exercise E says that we have to start from this URL here that points to a Git repository, and we have to use this to download the source code of the manual, and we have to define we have to make these things work using code CDs. And here people will have to consult the spoilers because it's not clear what this directory means. I mean, to what directory this thing has to point, and to what directory this thing has to point, whatever. Anyway, I can type meta h lowercase g here, and it runs a function called find git links. And now I can run this script here, and it clones the git. Oh no! It used the wrong directory. Let me fix that, sorry. So now the cd worked. It's downloading, it's cloning the git repository. And if I want, I can inspect the git repository using these links here. But I do not want to do that now. What I want to do is that I want to create something like this, but with a different name. I want to use something different instead of PGF here. So let me copy these 2 lines to my notes. What I'm going to do here is that I'm going to replace PGF by tiks git. Tiks is actually PGF tiks, but the name PGF is not used so much, so I prefer to use the name tiks almost everywhere. So this thing here defines this function code tiks git file and several other functions. Remember that you can inspect what this code cd does by running a exp like this. It defines this variable and lots of functions with tiks git in their names. And if people need more information about how this works, they can use these links here to go to the tutorial. So if I run this, then I define find tiks git file, find tiks git grep, and other links like this, and this one opens the source code of the manual. And I also need some variants of this. Let me open the spoilers. Here. What I really want is these 3 code CDs here, and this one is obvious. It goes to the copy of the git repository. This one goes to the directory where the source code of git itself is. When you use package git in your tech file, it loads files that are originally here, but that are then copied to the tech live distribution. To the tech live directories. And this one is going to be very useful and very used. That is the source code of the manual of Git, of tiks. So here we have all the sections and chapters and subsections and whatever of the manual in tech files. We're going to use that soon. So now, the exercise E said that we had to produce these 3 code CDs that make these secs work, and now they do work. This one opens the copy of the manual. This one goes to the source code of tiks itself, and this one opens the source code of the manual. So now let me go back to the exercises again. We have just done this exercise here. Let me copy these 2 exercises to my notes at the same time. This exercise here asks people to put more things in their init file. It asks people to copy these things to their init file, and it recommends using the spoilers. And the idea is that we are going to copy this thing here to the init file, and remember that if we type meta 55j, then we open the init file. So let me copy this to the init file, and note that it has a from line here, and the line with the from can be used to, I forget things all the time, and so I use these things to go back to the places where the functions were defined, where I found the instructions, and so on. If I execute this thing, I go to the temporary buffer with spoilers, and I see this block here, that is where this thing here came from. Now the exercise G, called page, asks us to create links to a certain page to the manual. If I execute this thing, it goes to the conversion of the manual to text, and the exercise says that we have to produce a pair like this that points to that page. And what we have to do is that we have to go here, then we have to mark this string and copy it to the kill ring, and then we have to type meta h, meta p. And then this is the thing that the pair that we want. This first link here opens the PDF of the manual at that page. Those coordinates appear here in the middle of the instructions for drawing this envelope here. And now this thing here has a number here saying to this function that it has to count the form feeds to go to page 13 in the conversion, and then it has to search for this string in the manual converted to text. If I execute this, it goes exactly to this page, but it also has this indication that we are in page 30. Sorry. Next exercise, H. In this exercise, we have to learn how to create a link to the source code of the manual. And we are also going to have to learn how to use this. This is a 5-minute hack in the sense that I've mentioned earlier, and that is explained. The design decisions behind these 5-minute hacks are explained in my talk at the MXConf 2020. If we execute this, it creates a temporary buffer with lots of hyperlinks. And the idea is that we have to understand what these hyperlinks do. And we have to produce a hyperlink like this that points to a certain section of the source code of the manual. Note that we don't have links like that here, but we will have to use the grep. We have to use this thing here to grep in the directory that has this shorthand. It found one occurrence of this string in this file here. So what we have to do is that I have to visit this file. It goes, if I type enter here, it will go to the line 271. Then I'll have to copy this thing to the kill ring. And now the best way to create a link to this string is to use, the traditional way is by typing meta-h here, and then duplicating this line, editing this line to add this string here, and so on. But one of the things that I'm going to present in the next MXConf is a very fast way to create links like this. So if this thing here is in the region, in this case the region is not active, but it is there, and I type meta-x klfs. This kills a link to a file and to a string in that file. So if I run this, God. Oh no, this is not loaded by default. Let's see if I'll have to fix this later, but let me go to fix this by hand, sorry. Let me see if this works now. Yeah, sorry. Let me do some mysterious things right now. I have to use these aliases here. Let me put these aliases in my... let me copy these aliases to the init file. And execute them. So now this thing should work if I mark the region here and I type klfs. This should put in the kill ring a link to this file and to this string in this file. Oops. Let me run this again. The message in the echo area says that this has killed this exp here. And let me go back to my notes. This is the link that the exercise asks for. If I execute this link, I go to this file and the source of the manual, and it searches for the first occurrence of this string there. Next exercise. Let me go back to my notes. It says start from this hyperlink and make sure you know how to use all the hyperlinks in the temporary buffer that this function here has generated. This first line here just regenerates the buffer in the sense that if I make a big mess here, I can just execute this and it will reconstruct the buffer in the original way. This second line uses a synonym for tiks. This third line here goes to the definition of this function. It is here, and after the definition we have def alias. So the two functions are equivalent. This thing here is going to use wget to access one of the files in my home site, in my home page. It has some notes about tiks, and here is an index that I've prepared for the chapters of the manual, but this index supposes that we are using an older version, long story. So the pagination is not correct. For example, probably this thing thing here is not going to point to no, this one works, but let me see what happens here. This one is 4 or 5 pages behind. The right value here should be something like this. Almost. Anyway, this is an index for the chapters in the tiks manual that is not going to work for you because, well, in the other exercises I recommended downloading the current version of the manual. And note that this thing was downloaded by wget, so it's in a temporary buffer. In this case, this link is not going to work very well because this thing is not the name of a chapter, it's the name of a subsection, but whatever. This link here is not, it's more like a button than like a link. It puts this string in the kill ring. We're going to see soon how to use that. This thing here opens the manual in PDF. In its page 3 where it has the table of contents. This one here opens the page 3 using the conversion to text. And now we can use this thing here that I have just pushed into the top of the kill ring to search for a certain string. If I go here and I type Ctrl S, I enter the mode that performs interactive search. If I type meta-y here, it puts the top of the kill ring here, and I can use that to find this section of the manual. And now I can search for other occurrences here because probably I do not know a link to this page. No, sorry, let me change the exercise a bit. I will use this link here to create, to create a link to the index. So this thing here is section 14.2.2 that appears here in very small letters here. And after doing that, I can also search for this other string here and use meta-h, meta-p again to produce a pair of links that go to the Rio section in the manual. So this goes to this section here. And this goes to this section converted to text. Let's go back. I was explaining the lines in this temporary buffer here, and this one was a bit mysterious. I have just explained how to use it. These lines here, in theory, they go to the section of the manual, to the index of the manual at the very end. And remember that you can execute this to go to the source code of that function. And we can use that to change that to the right numbers. This is a bit advanced, but let me explain it anyway. The index is a few pages ahead of that number. Let me see how many. Oh no, many pages. So in this version of the manual, the index starts at the page 1271. instead of 1235, and I can go to the source code of this function, and I can change this to 1271, and then I can redefine this function, and then I can use this to regenerate this buffer, and now it has the right links to the index. So this first link here goes to the beginning of the index, but it ignores this string. And this other link here goes to the beginning of the index, and then it searches for the string. I guess that is not going to work. It says search failed, but wherever. For other strings, this would work very well. For example, if I wanted this, then I could use this thing here to create a link to where a certain string appears in the index. Well, as I've said in the beginning, this is a 5-minute hack with many small hacks inside, and I've just explained how we can fix the index and how we can create links to an entry in the index. These 3 lines are easier. We just saw what they do. This goes to the copy of the Git repository. This one goes to the source of the manual, and this goes to the source code of tiks and PGF themselves. We can use these 3 grep links here to search the whole copy of the Git repository, or to search just the source of the manual, or to search just the source of tiks and PGF. And note that I've used an uppercase R here to specify that this grep has to be recursive. So this one finds one entry, this one's also, oops, and this not appears in the source code of tiks. I mean, when people run use package tiks, then this loads lots of packages, and this string does not appear among these packages, these tag files and the style files, these things that are loaded by use package tiks. And we can also use these things here to go to the, oops, I do not want to do that now. Sorry, I'm in the fake home directory. But we can use this to open the Git repository using a browser. So these are the explanations for all the lines that appear. Make sure that you know how to use all the hyperlinks. There are many, and some are quite technical. I've just explained all of them. So this was exercise I. Let's go to exercise J. Exercise J says that we should start by this hyperlink here, and we have to use this to produce links to a section of the manual. So this is similar to what I did here, but here I produced links to a section called horizontal and vertical lines. It's actually a subsection, or a subsection, wherever. And let me show how we can do this. My favorite way of doing this is by opening by using this to put this string in the kill ring. Then I go to the table of contents. Then I search for that string. It's in this chapter here. Then I go to that chapter with Ctrl S and Meta Y. And then, oops, sorry. Ow. And then now I will create a link to this string here in that page with the right number of spaces here. So let me put that in the kill ring and meta H meta P. And this is a pair of links that point to this section in the manual. Here we are. And this one opens that section in the manual converted to PDF, to text. So this was exercise J. And the next exercise, exercise K, is similar to that one, but it asks us to create no, sorry, this one is different. This one starts with it says that we have to start from this hyperlink, and then we have to find the source code for a certain example. We have to use this link here to find that section in the source of the manual. Let me first create a link to this string in this file. Let me copy it to my notes. I have just created something that is useful to me, but that is not exactly what the exercise asks for. That is a link to a certain section of the manual in the source code of the manual. And now that I have this link, I'm going to search for a certain code example here. It is here. Now I have to run meta-x tick here. And then I will change the body of this example by the body of this code example in the manual, this one here. And now let's test this. It worked, and ta-da! We are almost at the end. Let me see what is the next exercise. We were at exercise K. Now we have to do exercise L. This one is similar to the previous one, but instead of using tiks body, we have to put this string in another variable. This link here searches for this string in the source code of the manual. I want this code example here. And now I create a block like this one, but this block here is going to have an empty tiks body, so it's going to produce an empty figure, and I'm going to copy this thing here to the variable hello. The name is a bit silly, but the thing is that sometimes in some of my early tests I just did, one second, I just did this with an empty body, and when I run this block here, it just says that it just shows a hello. That is, I mean, it runs this code here outside the tiks block, but the hints say put this thing here in the variable hello. If we want more information about what this does, we can go to the source code in Lua. Sorry for the lack of colors, I forgot to install Lua mode here, but the tech body is here, and before this block here defines a tiks picture inside the scale box, and just before that I have a hello. Anyway, the exercise asks for this, and if you run this thing here, it runs this very low level comments here. PGF keys is the low level way to define styles in tiks, to make a very long story short. So the output of this is the result of these two things here as text. This is super technical, I'm not going to explain that now. But let me go to the exercises again. We have just run the exercise L. Now we have the exercises M and N. M is also quite technical. People are going to need something like this if they need to run advanced examples from the tutorial. Let's first search for magnetic field in the manual. If we simply search for the first occurrence of magnetic field in the manual, it is probably in the page 565 or 566. So let me start by creating a links to this page of the manual. Here we are. Let me copy them to my notes. The string magnetic field appears here in this figure. And if the string appears here, it's because it also appears in the source code. So let's search for it in the source code. Here it is, magnetic field. The exercise asks us for use this thing here to find the first occurrence of magnetic field in the source code of the manual. So we have to use this grep here. Now let me use this link here. And now the exercise tells us to to create a tiks block that runs this example here. But this example is not just a tiks picture. It also has some extra options here in the just after the begin code example. If we just create a tiks block that runs this thing here, let me put that in the tiks body. And let me try to execute this thing here. The show, instead of saying success, it says that we had an error and it does not know how to explain what is that error. So now we can run this thing here to show the log of PDF LaTeX, sorry, of Lua LaTeX, and the log says this. It says that it doesn't know how to run canvas something here. It doesn't know how to run this. And the trick is that we need to set this preamble somehow. And the exercise says what we have to do. It says that we have to say to load this library here, and if we run this new version of the pitch block, now we have a success here. So it's created a PDF correctly. The log says the details, but it's not very important now. And ta-da! We were able to extract that example from the manual and to create an pitch block that runs that example. So this was exercise M, and now we have a very technical exercise. I mean, most people who use LaTeX are going to find it completely mysterious, but let me show it anyway. The last exercise says that we have to execute the test blocks in these files. This one here goes to the copy of this file in my site. It uses wget, and this one goes to the local copy. Let's use this one. So let me spend a few seconds more to load Lua mode, because this thing is going to be much more easy to understand if I oh no, I'll have to cheat a bit. 1 second. You are not expected to understand this. Let me run this thing again. Now it's going to load all packages from Melpa, and it's going to display them. It takes a long time. Wow, it's taking much longer than I expected. Whoops. Let me install this thing. it's installed. I forgot to copy the last exercise to my to-do file, to my notes. Now I've copied it. Now if I open the local copy of this Lua file here, it's probably going to use to be able to fontify everything correctly. No, it didn't. Anyway, sorry for not having installed Lua mode before. Anyway, now we have the colors and we can see clearly that this thing is a big comment and this thing is a test block, and we can run this test block here to understand how these functions work. And this is the super technical thing that I wanted to explain. This line here says that we will prepare a tag file that will not generate a PDF because it will stop in the middle of the execution when Lua-LaTeX is trying to compile it, and it will stop because it will run a REPL and not the default tag REPL. It will run a REPL in Lua that is defined here. Here we have an explanation. It says that when we run this, then tag body will include this block of code here, and this block of code will load a certain Lua file into Lua-LaTeX, and then it will run the REPL that is defined in the very mysterious way. Anyway, let's run that in practice. If we execute this, then I have just saved the tag file. I have not asked my Lua files to run LaTeX on it. And now I'm going to run Lua-LaTeX on it inside a shell here, inside another REPL that is running a shell. If I run this, then it starts the compilation, and then it gives this prompt here. And this prompt here is a Lua prompt. And now I'm going to run these things here. For example, print meaning new page will run a certain mysterious thing, and we'll say that the definition of \new page is this thing here. So a new page, \new page is a tag macro that is defined in this way, and this print meaning here will do something similar, but it will use a very low-level trick to discover what is the current meaning of rounded corners for tiks. So rounded corners has this definition here, and this thing is the same thing but in a shorter version, and this thing is same thing in an even shorter version, and this one shows the definition of right that we use sometimes to specify how labels have to be placed. So this is a way to inspect definitions from inside the Lua REPL. It's something super tricky, and at the end of this page here, I'm not sure if the links are already there, but I'm going to explain to give some links about how these things work. No, I don't have the links right now. I had to ask some questions at Stack Exchange and Stack Overflow to understand how to do these things, and The whole story is that I wanted to do something much more complex. I wanted to be able to expand PGF keys from this REPL, and then I asked the question, and then people explained to me why this was impossible. And so what we have here is something much more humble. Instead of expanding definitions using PGF, this thing here simply shows what is the current definition without any expansions. This is a long story, it's super technical. I'm going to explain more about this in the page at some point, but it's, I mean, here. No, I mean here, but it's not ready yet. And so that's it. This finishes all the exercises. Let me stop the video now, and then I'm going to put more material in the page, and I'm going to add subtitles to this video so that people can use the subtitles to see how to perform the exercises. So that's it. Bye.